We need a few more definitions. I'll give some examples too. I'm going to probably skip some proofs to try to get to Galois theory quicker. Maybe go back later and do them. So when you have a group, if xy equals yx for all the elements of your group G, then we say it's an abelian group, or we say it's commutative. You know, the elements commute with each other. So abelian or commute if xy equals yx. If S is a set, then if you have like absolute value bars around the set S, then that's going to give you the number of elements in the set. Like if you have the set with the elements AB, if you put that around it, that'll be the number 2, because there are 2 elements in that. If it's infinite, then it's going to be equal, instead of the number of the elements, it's going to be the cardinality. And I would like to do a whole series on cardinality, but we can't do everything at once. But that's an interesting subject by itself, because not every order of infinity is the same. Like the natural numbers are countable, the irrational numbers are not countable. There are a lot more of them. You cannot line up the counting numbers 1, 2, 3, 4, 5 with the irrational numbers, because there's so many more of them. So if they're infinite, that absolute value kind of thing around the set denotes the cardinality. So if you put that around a group G, then that's the order of G. That's the number of elements in the group G, the absolute value. And if H is a subgroup of G, then H is a subset of G, and H is a group in its own right. If H is not equal to the identity and not equal to the whole group, then it's going to be a proper subgroup. So those are all the different basic definitions: abelian, the order of a group, and a subgroup. So we'll move on from here. Thank you.